All right, let's get started with 4-5 complex zeros. So complex zeros. So we've learned so far that if we have an x to the fourth problem, we can have 4 zeros. And up till now, all of them have been real zeros. But what we're going to find out is that these can be split up into real zeros or imaginary zeros. So we need to go back and remember what an imaginary number is, something like the square root of negative 25, which would be 5i, right? So we can have real numbers and imaginary numbers, and if you put those together, we get complex numbers. The complex numbers are real plus the imaginary. So all imaginary plus all the real, you get the complex set. All right, so we have the n zeros theorem, and all this says is that if you have an x to the fourth, you have exactly 4 zeros, some imaginary, and some of them real. Okay, so let's talk about our imaginaries. Anytime you have an imaginary number that is a solution, so let's say we have something like 2 plus 3i, you will have what's called its conjugate. So a conjugate means its partner with an opposite term. So 2 plus 3i, you would also get a 2 minus 3i. If you had negative 5i, you would also have positive 5i. So the imaginary numbers always come in a plus-minus pair. Okay, so let's see how that works out for some of our problems. So let's find our complex conjugates here. Find our zeros. So x squared minus 4x plus 13. Can we factor this? Is there any way to multiply to 13 and add to negative 4? There is not. So our optional option is to do the quadratic. X equals negative b plus or minus square root 16 minus 4 ac all over 2a, which will get us 4 plus or minus 16 minus 52 is negative 36 over 2. And so we'll get 4 plus or minus the square root of 36 is 6i over 2. And so if we divide both of them by 2, we'll get 2 plus or minus 3i. The plus or minus, there's our two answers. So we have 2 plus 3i, and we also have 2 minus 3i for our zeros. And how many zeros should we have? We should have 2 of them. So we found them both. Okay, so how do we use this in figuring out what the polynomial is? So in the past, if I told you that the 0 is negative 2, you could write the factor x minus negative 2. Now, we probably wouldn't write that. We would just go straight to x plus 2. But you can always write x minus the 0. That's the factor. If we get an imaginary 0, 1 minus I, we can also write x minus the 0, 1 minus I. And we'd also have x minus plus I. So if we sorted this out, we would say x plus 2 times x minus 1 plus I and x minus 1 minus I. And our job here is to find the polynomial of minimum degree. We've got to FOIL this all the way out. So we're going to start by multiplying these two together. Let's use the box method. We haven't done this in a while. X minus 1 minus I times x minus 1 plus I. We'll get x squared minus x minus ix minus x plus 1 and positive I here. And we'll get ix here. And we will get negative I, and we will get negative I squared, which, if we remember, is the same thing as positive 1, since I squared is negative 1. So that cancels that. That cancels that. We're left with x squared minus 2x, from here, 1 from here, plus 2, 1 from here and 1 from here. Okay, we still need to multiply times x plus 2, so we'll do the box method one more time. Get x cubed, negative 2x squared, 2x, x squared, negative 4x, and 4, x cubed, those cancel, minus 2x, and plus 4. as our final polynomial. All right, your turn. See if you can do it. So what do we have here? We have x minus 1, x minus 2 minus I, and x minus plus I. And this is going to turn into x squared minus 4x. And then this would be plus 4 plus 1 more plus 5. And then we would have x minus 1. We'll have x cubed, negative 4x squared, 5x, negative x squared, 4x, minus 5. So our final answer, x cubed minus 5x squared plus 9x. 5. Okay, so now we're going to go into factoring with complex zeros. So for this, we're going to do just what we did last class, or if we need to factor an x to the fourth, we're going to put in our graphing calculator, we're going to find the real zeros, and we're going to start with synthetic, right? Remember that since this is x to the fourth, we expect 4 zeros, so make sure we get all 4 of them. Okay, so I went ahead and graphed it. It looks like it crosses here at -2 and here at +3. So let's start with that. -2, we'll go synthetically. 1, -1, -5, -1, and -6 for our synthetic. 1, -2, -3, 6. 1, -2, -3, and 6. So that one checks out. And we'll go again with what looks like +3. 1, 3, 0, 0, 1, and 3. That one checks out as well. So what do we have here? We have x plus 2 from up here. We have x minus 3. And then we have x squared plus 1. Now, x squared plus 1 cannot be factored, so we're done. The x squared plus 1, that's going to be 2 imaginary solutions. So in this one, we have 2 imaginary, and then we had 2 real. And we are completely factored. All right, see if you can do the same thing. Go ahead. All right, so we've got, it looks like 1 and 2. So, you know what? On this last one, I apologize. They told you that I is a 0. Okay, so that one does check out also. This would be I in there. But we don't really need it if we've got the graph coming in here. All right, so let's start with 1. 1, -3, 6, -12, and 8. 1 and 1 and -2. -2 gets us 4. 4 gets us -8. And there we go. We'll go again with 2. 1 and 2 and 0 and 0 and 4 and 8. So there we go. All right, so we have x minus 1, x minus 2, x squared plus 4. All right, so the rest of these are just more examples of the same. So let's just do one more here. I think we want to just do that. Let's see. Yep, they're all just the same deal. So let's try one more together, and then we'll be done for today. So on this graph, here we go at -1. Synthetically, 1, -2, 1, 2, and -2. 1, -1, -3, +3, 4, -4, -2, and 2. Keep going with 1, 1 and 1 and -2, -2 and 2, and 2 and 0. And so there we go. We are left with x plus 1, x minus 1, x squared minus 2x plus 2, which does not factor. We are done. All right, good luck with this. We'll see you in class.